Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2007, 10A, Problem 15, and it deals with geometry. I hope you all enjoyed this video and let's get started. The problem states 4 circles of radius 1 are each tangent to 2 sides of a square and externally tangent to a circle of radius 2, as shown. What is the area of the square? Okay, so in this question is asking us to find the area of the square. And so looking straight at it, we would think, or I would think that, we can use Pythagorean theorem because Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the side lengths of a right triangle. And because this is a square, that means this is a right angle. And so what if we just connect this? So passing through the centers of the square and connecting it, like connecting the diagonal, that would be the hypotenuse of the triangle, and we can just use Pythagorean theorem. But the problem is that we don't know what the hypotenuse is, because although we do know the radius of the circles, so for example, this little portion would be 1, 1, 2, 2, 1, 1. That's the center of that circle. If we add those up, that's not the hypotenuse here because we are missing out this small portion and this small portion. And we don't know how long that little portion is. And so we cannot use that because we're kind of overlooking. So just to make sure that all of the measurements are precise and they're like connecting to where they're needed to be connecting to. So we can't use this way, but if we look at it from a different angle, we're trying to find this, right? The length of one of the sides of the square. But if we look up and see that, I'm just going to draw out the centers of the circles really quickly. And so if I connect it, if I connect all of the centers of the smaller circles, we actually get a smaller version of the square. And we do know the length of the square. And this is because if we connect the diagonal, we do know the diagonal, like this diagonal, the measurement, we do know because it tells us that the radius of the bigger circle is 2. So that's 2, and then we have 1 and 1 right here. So 2 plus 2 plus 1 plus 1, that is 6. And so this is the diagonal of this square is 6. And then we can use Pythagorean theorem, as I stated previously. Because it is a square, that means that I'm just going to let this be A, one of the side lengths of the smaller square. That's going to be A, and then this will also be A because they're the same because it's a square. And so Pythagorean theorem states that a squared plus b squared equals c squared, where, as I stated, that c is the hypotenuse of a right triangle, and then a and b are the lengths of the legs. And so we here know that the hypotenuse is 6, so 6 squared. That is equal to a squared plus a squared. And this is because, as I stated, that is a square, so legs are the same length. And so it would be 2a squared equals 6 squared. 2a squared is equal to 36. Okay, so a is equal to 3 times radical 2. So that is the side length of the smaller square. But then all we have to do now is to just add up the radius of the smaller circle, because as we see here, we cannot figure out this line. But keep in mind that this line and this line, that's the exact same thing. That's all. The measurements will be the exact same. And so if we figured out that A is that this portion right here, that is 3 times square root of 2, all we need to do is add 1 on each side, so that's 2. So all we have to do is 3 radical 2 plus 2 is equal to the side length of the square that we're trying to solve the area of. And now all we have to do is find out the area, so we can just square this. So it would be okay, so I just solved for this, and I solved it by using a rule of a binomial. So basically, it says that the quantity of a plus b squared is equal to a squared plus 2ab plus b squared. And so this comes in so handy because you can solve it so fast and it saves you so much time, especially when taking the AMC. And so looking at the answer choices, the answer is B.